So we're starting to talk about arithmetic sequences. And what these are is they're sequences of numbers that are special. And I'll just give you a regular old sequence. There's nothing special about this one. Let's say 3, 4, negative 1, 12, 0, and on and on and on. And I'm trying to make these numbers random. They should appear random, but there's no pattern between them. This would just be called an infinite sequence. And the reason I'm calling it an infinite sequence is because of these little dots over here, right? See these dots right there? That means it goes on forever. And since there's no pattern to the sequence, I'm not going to say anything else about it. It's just a sequence. Now, in arithmetic sequences, we're talking about more special sequences. These would be things like, 3, 4, 5, 6, 7. Okay, each time you make another number in it, you add 1. So you could predict what comes next. It's 8, right? Or you could have 3, 8. Let's see, that's plus 5, right? So we went up by plus 5 there. And the next one in this sequence would be 13, and then 18, and then 23, and so on. And you see each time we go up another number, it's going up by the same difference. It's plus 5 each time. That's called a common difference. So now you've got this idea of an infinite arithmetic sequence. And I don't mean to say that all sequences are infinite. That's not true. Some of them don't have these little dots right here. So maybe like this. Now it's just a regular arithmetic sequence. There's no infinite to it. And there's two formulas that allow us to work with arithmetic sequences. One is called the recursive formula, and one is called the explicit formula. And these try to put a little bit more of a math spin on what are just patterns, right? So if we can use a formula to predict the pattern, then we don't have to count one number at a time. If I wanted to know what the 200th number in a sequence was, I could spend a long time just counting my way there, or I could use a formula to get there. Now, the recursive formula says that any number in a sequence, and I'm going to call that an, that's any number, equals the number before it. Okay, so n minus 1 is pointing to the number before it plus a common difference. And that makes sense, right? A version of this thing, let's get rid of the n's for a moment. Let's say a3. Okay, a3 equals the number before it. That was a2 plus d. And if I'm going to use this sequence as an example here, that would be, let's see, the third term is 13. 13 equals, the second term right here, that's 8 plus d. And the common difference was 5. So you can see in that simple example how the recursive formula is used. It's not especially useful. You really only go one step at a time with it. The explicit formula is more useful. That allows you to go multiple steps at a time. And we'll get on to how you use this in future videos. But it's an equals a1 plus n minus 1 times d. And just a quick example, let's take this series right here. I'm going to use this one again. I'm going to say, what is the 200th term in that sequence? And let's say a1, well, that's 3, plus, n is 200, right? I established that right here. So if I say n minus 1, well, that's just 199. And d is 5. So, that's math. Let's see. 200 times 5 is 1,000, so this must be 995. So that means the 200th term in this sequence would be 998. And that's the way you use the explicit formula for an arithmetic sequence. It helps you find numbers that are way down the line and that you don't want to really count your way to.